Yeah? Yeah. All right. All right, here we go. Everyone, Feihan Xu. I'm here to talk about asynchronous I/O in Python 3. This talk basically all begins with this PEP called 3156. The official title is Asynchronous I/O Support Rebooted. Basically, it describes a new event loop implementation, and one of its goals is that it be compatible with the current existing event loops. So primarily twisted, but also like tornado, etc. And right now, it's slated to land in Python 3.4. So not the current version. The current version is 3.3. And probably, early 2014, hopefully in time for the Montreal PyCon. Oops. The big takeaway is that with what Guido is working on right now, we should be able to write asynchronous code without threads or callbacks. And I should, actually say a little here that what Guido is doing is, I don't feel it's like not invented here syndrome. It's not like he just wants to. It's not like he just doesn't like Twisted and he wants to make his own version. I think like the model he's going for is something that we're all sort of trending towards in the programming language world. For example, we already see it in Node.js. They have this thing called fibers, which is essentially the same idea. And I'm pretty sure Ruby people are probably looking at this, and I'm not a Ruby person, but if I was working on the railroad and one day there was a huge accident and a huge iron spike went through my head and my personality totally changed and I all of a sudden started liking Ruby, if that happened, I was a Ruby guy, I would be like, oh, well, Node's doing it, Python's doing it, I guess we should do it too, just with some more monkey patching. And so we're all moving in this direction. So it's a thing that we're probably going to run into unless you're doing PHP, I guess. All right, so there's been a huge debate that's raged for, I don't know, decades now about threads versus event loop. I'm not going to talk about it because that's not the subject of my talk. I think Twisted being around for so long kind of more or less justifies that the event loop is a basically good idea. You can follow this link here later if you want to see more details about this particular discussion. But I am interested in telling you about the differences between Twisted and Tulip, and I could just give you like a list or a spreadsheet or something, but instead I will use an insane analogy. So when you're programming Twisted, actually raise your hand if you've done any programming with Twisted. Okay, so some people will know exactly what I'm talking about. So when you're programming Twisted, it's kind of like being a mystical ninja warrior. Okay, and I need to make it clear that you're not like a run-of-the-mill ninja warrior. You're mystical, and there's like a big difference. I think there's a certification you have to pass. Okay, so because you're not like taking on random dudes, right? You're fighting demons and demigods. And the only way you can do that is if you clone yourself. You have to make an army of shadow clones, right? Concurrency. And the thing is, like, this is not easy. Like, there's like huge amount of mental gymnastics that it requires, and you have to train for years and years, and you might die. And also, we all know that ninja magic always comes with a terrible price. You don't just like wave a wand and something happens. You have to sacrifice something. In this case, the more clones you make, the more insane you become. Right, so like Twisted people, like you should be nodding, right? This is exactly how it's like working with Twisted. It's kind of cool, but it's also insane. So on the other hand, if you're programming, asynchronous code with Tulip, it's more like playing Plants vs. Zombies. Okay, so if you're not familiar, it's a computer game, and what you do is you have to fight these zombies that want to invade your home. And the only weapons you have are like these plants, and you just plant like a ton of plants, but you also have to manage them because a lot of plants have certain things, and you have to like click on them or something. So, the game basically involves like dragging and dropping and tapping on things very quickly. I'm basically saying like it doesn't require any training. Like you just pick it up, right? And also, sometimes you end up playing for hours and hours without eating or sleeping because it's just that easy, right? It's a casual game. So, I mean, I think you understand what I'm trying to say. I'm not going to explain this analogy further. I will make a confession, though. Like that whole analogy part was like the meat of my talk. And like you could probably leave and you get the gist of it. The rest of the talk is just frosting. But we all like frosting, right? So I'll just keep babbling. Okay, so before I can really show you what Tulip is like, I think I need to revisit what sort of the current state of affairs is now. So here's an example of how we might fetch a web page in Twisted. And this sample is a little bit longish, but if we go to the end there, that's the important part, right? Whoa, what is with all this flickering? I mean, it's connected. Okay, I don't know what's going on. Oh, it's not flickering anymore. That's good. Oh, no, okay. Whatever. So here's the important part, right? You create an agent object, then you call the request method on it. It doesn't return like a result right away. Instead, it returns a deferred. And then what you do is you add a chain of callbacks on the deferred for each stage of I/O that you need to make in this program. Okay, so after, oh, I'm not sure about that. So after you so the request method, the result of that is the headers, the response object. So that gets fed to this callback, and that gets sent to print headers. And then afterwards, we make another request for the request body, which gets handled by print body. After that's done, we head to this anonymous function, which stops the reactor and terminates the program. And it just goes like that. It's pretty easy to kind of see what's going on. But the one thing I should note is that it seems like there's only 3 callbacks in this program. That's actually not true. There are 5 callbacks. Because if you look at the body of get response body, you have to do this sort of weird thing where you, if you want to get the body, you see this deliver body thing, you have to pass it a body receiver object, which is a subclass of protocol, and like my head is already hurting right now. So yeah, there's like 5 callbacks, because Twisted is all about callbacks. All right, so let's look at what it's like in Twisted. Or sorry, that's okay. Yeah, I didn't do this. I got sleepy. I went to bed. Okay, so you could see a little bit from the example some of the problems with asynchronous-based code, or callback-based asynchronous code. One is that it can be a little difficult to understand the control flow. Also, error messages tend not to be very friendly because the stack trace is going to contain a lot of stuff that contains code that you didn't write. Right? It's going to contain a lot of the reactor code from Twisted. Also, debugging is a little bit harder for kind of the same reason. When you're in PDB, for instance, and you try to go up a frame, you're not going to go into something that you wrote. You're going to go into like reactor internals. All right, so here's the equivalent example in Tulip. You can see already it's way shorter, right? It does pretty much exactly the same thing. There's really no callbacks unless you count the fact that here we call the download function once to get the coroutine, and then we execute the coroutine. So maybe there's one callback, but like there's only one. And you'll notice that we're doing this thing with yield from here, which hopefully I'll explain adequately later. But yeah, it's simpler, right? But I'm trying to be a little fair here. So Tulip does have callbacks. It has callbacks because we need to interoperate with Twisted. So when we're looking at the callback example using the Tulip API, you can see that actually it's worse in some ways than the Twisted example because there's no callback chain. If you look at the main block, there's no callback chain. To understand the control flow, you have to like look at the end of each function because one function passes off control to the next function. You have to look at bleh. Okay, you have to look at the whole thing. So the callback API in Tulip is not very robust compared to Twisted. I think that's probably on purpose. I think Guido does not want you to use callbacks. And then here again, we go back to Twisted, because I'm insane. And here, this is actually an example where I'm using inline callbacks. Because in Twisted, it is possible to write some of your code using a callback list style. So here we have a download function that looks very similar, except we're using yield instead of yield from. And it all looks kind of nice, right? It's like, I can sort of deal with this. It's like, I don't need to be a mystical ninja. I'm not going insane when I look at this download function. But then, you scroll down a little bit and you look at get body, and it's like, okay, I'm starting to go insane again, right? Because you can't easily get rid of this data received and the connection lost callbacks, because you need to override them on like a subclass. And I think what this sort of tells me is that callbacks are sort of intrinsic to Twisted. You can only sort of hide them. You can't get rid of them completely. And that's why we need something like Tulip. All right, so the Tulip API, I'm going to actually start getting into it. It's mostly defined in PEP 3156. One thing to note is that Tulip is not available in the Python package index. You can't do pip install Tulip. It has all the stuff that you would expect, kind of low-level sockets file. It also has concurrency data structures, which you think you might not need, and you technically don't, but they're still useful, right, to help you not shoot yourself in the foot. It also includes SSL and HTTP. The surprising thing is that it actually supports WebSockets, which last time I checked, Twisted.web actually didn't support yet. So I need to address the issue of coroutines versus tasks, because this was a thing that really tripped me up when I first started working with Tulip. Basically, you can just, if you look at something, and like a coroutine is something that needs to be executed by yield from, and then a task is not. You don't need to use yield from. I'll go into a little more detail. So coroutine is actually basically a Python construct. It's not something that it's something that Tulip uses, but it's actually just part of Python. So it's a function that contains at least one yield from statement. But you don't want to confuse it with a generator function, because that's a function that contains a yield expression. And so I'm not going to go into differences, but I would say that yield from is sort of more flexible than yield. And actually, Tulip will only accept coroutines. It does not accept generator functions. It'll actually throw an error if you try to feed it a generator. So here's an example of a coroutine. You've basically already seen this before. That was in the previous example. You have to call yield from, because tulip.http.request, this function, it gives you a coroutine. But the coroutine object is just an object. It doesn't execute any code. You have to call yield from on it for the body of the coroutine to actually be run. And then a task, basically, it's a thing that wraps around the coroutine. But because it wraps around the coroutine, you don't need to call yield from on it. It sort of handles it for you. And it's actually roughly equivalent to the deferred object from Twisted. And here's an example, one example possible way of using a task. So actually, if you look at the previous slide here, you see I had a tulip.coroutine decorator that sort of marks it as a coroutine. Here, I have the same function, but I use tulip.task. So this function is actually still a coroutine, because as I said, as long as it has yield from, it's still a coroutine. But now I'm decorating with a tulip.task, so it gets turned into like a task wrapper function. And then you don't need yield from to make it run. And then I'm going to beat this into the ground. So like this is also confusing. There's two types of, there's a tulip.task and tulip.task with a capital T. The difference is one is a decorator, and then the other one is a constructor that makes a task object. I don't know. Maybe I'm going a little insane. I don't know. All right, so why do you even need to use tasks? Because tasks are associated with callbacks, and we want to avoid callbacks, right? Well, we still need them because we want to interoperate with Twisted. And then it's nice to use a task because it has a cancel method on it, so you can cancel like a coroutine that's running. And also, if you want to start a new coroutine within a different coroutine, a task is one way of doing that. Yeah.
Like you can set like a timeout. You can say cancel this at the 600 milliseconds or whatever.
Yeah. So the question is, can you set a timeout to cancel it if it's running too long, right? Yeah, you could use a task for that. Okay. So then there's the concept of the future. And I didn't actually want to talk about it because there's two features in the Python library. There's tulip.future and there's concurrent.futures.future. And concurrent.futures.future is actually already in the standard library. It's already in 3.3. The difference is like one is for threads and one is for the event loop. Otherwise, they have a pretty similar API. I don't know, you're probably going to get them confused anyway. So how does Future connect with Task? Well, Future is a superclass of Tasks, so it has all the stuff that Task has, it comes from Future mostly. But the difference is that Future doesn't really necessarily have anything to do with a coroutine. It's a little bit more abstract. You don't actually use features, but internally Tulip uses them, and there's a lot of places in the API where you actually need to use them. And actually, features also are acceptable to yield from. So they're sort of equivalent to coroutines, but they're not actual coroutines and blah, blah. Yeah, I hate this part. Yeah, so there's some methods on Future, yay. Okay, so I'm guessing that most of you here are web developers, so you might be asking yourself, well, am I ever going to use this stuff? Like, is this good for web development? And I think, yeah, basically because Tulip supports HTTP, so it gives you everything that you need, really. It's all in the tulip.http module, and then basically you need to subclass the server HTTP protocol class, and then override handle request. And here's a little example. It's mostly boilerplate. Only part that's interesting is sort of in the middle where we're generating our HTML, and then we're writing it to the response. And we have to call .encode because it expects a byte array because it's Python 3. And yeah, if anything is like not clear, oh, Pete.
Yeah, where were the coroutines? Like, where's the yield from?
That is actually a really good question. So I marked this as a coroutine, but the truth is that tulip.coroutine is just for show. Like it does jack. This is actually not a coroutine because there's no yield from in it. But like it doesn't hurt if you call yield from in a non-coroutine. Like nothing bad happens. It just gives you the result of the function. Yeah, I don't know if it's a big deal, but like tulip.coroutine is mostly just used to mark your functions as coroutines, so you know which ones you need to execute by using yield from, which ones you can just call like a normal function, right? But in practice, like this is a very simple example. In practice, you'll probably will use yield from when you're writing like an actual web application. There'll be probably slightly better examples, maybe. Does that answer your question, Pete? Okay, yeah. Yeah, that's all I aim for, sort of, yeah. Okay, so some observations. You might have noticed that it's kind of the API is a little low level. It's just like WSGI. Like I wouldn't write a web application by like starting from raw WSGI, right? That would be insane. So there's probably going to be a lot of frameworks that are going to sprout around Tulip. And then speaking of micro frameworks, hey, I made my own just for this talk. All right, so it's a very small one, and it's not like Django or Bottle or Flask or anything like that. It actually uses a different model because Tulip is a different thing. So after you do your initial page load, all the communication between the client server is handled through WebSockets. And so and also the reason I made it is because the code demos, like if you want to do concurrency demos and you show them in like the console, it's going to be like so painful to watch because you're not going to like understand what's going on at all because it's just a bunch of text, right? So you have to do it a little differently. So it's going to run the visual part of the demo in the browser itself. So yeah, I'm going to give you a few demos and live demos. What could go wrong, right? And actually, I think here might be a good place to take a short break, and you can kind of digest some of the things that I dumped into your face. Oh yeah, sorry. Question?
So this seems really similar to Tornado.
It probably does because Tornado so the question was, it seems similar to Tornado, which actually that wasn't a question, but yeah, I think that's true, right? Because Tornado uses yield, right? But it doesn't use yield from, as I understand. Right. So, like I said, like the direction that we're going in with all this isn't new. I should have mentioned that in Python itself, we already have frameworks that do this callback list model. The main difference I would say, I think, between Tulip and Tornado is that Guido took extra care to make sure that the error tracebacks are a little better, and he claims that yield from is part of what helps with that. But I haven't used Tornado, so I don't know if that's true. Another question?
I'm not sure what yield does.
Okay.
Explain what these things do, sort of basic
So like yield from basically executes the body of the coroutine, because you understand, so the question was, what does yield from do, right? So in the coroutine by definition already has yield from. And inside of that yield from, it's yielding stuff, just like a normal generator function. So yield from in the context of Tulip, though, it's returning control back to the event loop. And the event loop does like run some other coroutine for like one slice or something, and then hands it back to the original coroutine. So like yield from is a way of handing control, of having multiple entry and exit points to a function. Does that make any sense, what I said?
One way I can think about like with Tornado is like, so what if you notice the yield from is like, he was trying to fetch a website, you know? So that takes time, right? Because you have to look through everything to do and stuff. Well, when you do that, with coroutine, what you're saying is like, so I'm going to ask for this third-party thing to happen, and then I want my process that I'm using to be used to do other things while I'm waiting for that response. So that's goes back to really the did on my process another user's response, or the request while it's waiting for that to come back.
Some sort of old school coding model is like giving up the lock, but setting a timer to
exactly. And what you're locking here is the whole process.
Yeah, there's no timers though. It's cooperative. It's like what's called cooperative sharing. So basically, it's like when one of those coroutines gets into, it will continue to like hog the CPU until it hits something you go from, and then it goes back to the loop and bounces into some random.
Yeah.
Have you looked at eventlet or gevent and compared it to these things?
So the question is, have I looked at eventlet and gevent and compared it to this? So I didn't, but I watched the keynote from Guido, and he did, and he had some choice comments on it.
I'm totally against Guido on this.
Oh, okay.
I'm like, those of us that have been using eventlet and gevent just think this whole thing is hilarious because we solve asynchronous.
Right.
Asynchronous problems a long time. I already gave a talk on it, I don't know. It's
right. Okay.
It's sort of something that has to resolve because we've been using it for a while and it's the best thing ever.
Right. Right.
But for whatever reason, and I think it's just because everybody that
Use it just kind of go, well, that's done, and we're done here. Nobody's talking about it. I don't know why.
Right. Yeah, and I don't think I can say anything more. Like Guido's argument against eventlet and gevent was mostly like he didn't like the patching that was going on, and he didn't.
It's hilarious because it's like, I mean, it's not
A problem with gevent and eventlet that they need to patch. It's a problem with Python that it needs to get patched.
Yeah, I mean, let's not get into that because we'll like kill each other eventually. Maybe. So we could do that some other day.
We're going to take a quick break.
Right,
One question. We have a Q&A after this.
Yes.
One more.
Plans to backport?
I think that, so Tulip is, he might as well have called this library carrot because he wants to dangle as a carrot for people to, right, to use Python 3 because the truth is not enough people are using Python 3. So I think like there are no plans at all to backport to 2.x. Yes? Okay, so who in the room is using Python 3?
There's 3.
Yay. You should all join our little club.
All right, so here's what we're going to take. Before we take a quick break, I'm just going to, I've already... All right, ready to go.
Save me, Jeebus. Okay. So I noticed a lot of people didn't come back. That's okay, right? Whatever. I said it's just frosting. I mean, whatever. You don't like frosting, that's fine. So as we're going to head into the demo portion, I just want to say that one thing I should have made a little more clear is that whenever you see yield from, that's an indication that there's some kind of inbound I/O happening. So like, for example, here, of course there's I/O happening. Like when you call response.write, obviously it's sending I/O out to the client, right? But this response.write, it returns immediately. Like it buffers it handles it internally. You don't need to worry about it. But like when you see yield from, like for example, when you were looking at the download function, like when you see yield from here, that means like there's some I/O, there's some bits coming in, and you're saying this yield from, like, I'm going to wait for it to happen, even though I know it's not going to happen right away. So maybe that makes it a little more clear. Maybe it doesn't. Maybe.
Can I ask you a question?
Yes.
How is that different from yield in parentheses?
Yield in parentheses in 2.7. That's just the yield.
No, I mean there's a you were in that David Beasley class where he showed yield versus yield in parentheses.
It's not so much in parentheses as that it can be an expression instead of statement.
Yeah, I don't want to get into differences between yield and yield from, and yield with parentheses. I don't think I totally understand. Yeah, like my response is save me, Jeebus. All right. Okay, so first demo. So we have an HTML file that we're serving up. So this is the initial page load, right? It's a very boring, page. It's got a button with ID of go. It's got 2 p tags, one with foo, one with bar. It's got another p tag that's going to act as our log. Okay, very simple. And then demo.py. So I'm using that little, framework I told you about. So when I say veal.connect here, and I give it a selector and an event name, what's saying is whenever on the client, someone clicks the button with ID of go, a message is going to be sent to the server, and this particular function is going to handle that message. So the code for this is actually pretty simple in Tulip. I'm not going to bother showing it to you. I'm just trying to demonstrate some very basic stuff. And then foo and bar are almost identical. It's just that the return value is different. One says foo is done, the other says bar is done. And then all they do is they make these so-called widgets, and then they display them in the client. They add them to the client. And the client being obviously the browser, essentially. So here I'm going to run the demo, and oh no, that's fine. So there was no, what happened is it jumped before the web server could start, so it's always going to do that. That's actually, whatever, I messed up. Okay. So look, widgets are being made. And all the demos are going to be this adorable. And you can see, basically, it's running serially, right? Foo runs, right? Because yield from causes it to wait.
Is this with WebSockets?
Yes, with WebSockets. Yeah, so all these widgets are being sent over the wire through WebSockets. And I actually put up Veal on GitHub so you can look at it, how it's written. It's still not very big. Yeah, so that's our baseline. So now we're going to look at the simultaneous version again. Yeah. So now they're going to run at the same time. So you can get the same number of widgets in a shorter amount of time. Yay, right? Okay, so the code is pretty similar. Index didn't change at all. Here though, so this got a little bigger. So I'm using the task API. And this is actually horrible. You should not do this. This is a complete anti-pattern. But this is the only way I could think of to do it when I first started using Tulip because I didn't know what I was doing. But yeah, you shouldn't, this is essentially polling, right? It's going in this endless loop and sleeping every 1 second to see if task 1 and task 2 are both done. And yeah, don't do this. Foo and bar are unchanged. So here we're going to actually, this actually, I don't need to really run this. I mean, this is exactly the same thing. But here, well, this is not exactly the same thing because the widgets are actually random because sometimes they're cuter and sometimes they're not as cute. Right, but in demo.py, I think the code is cuter, right? So what we do is we make a sequence or a list of coroutines, right? We make a foo coroutine, a bar coroutine. We pass them both through the list into tulip.wait. And I'm not going to explain this tuple done pending, but basically we go through the so-called futures, and then we just log the result. And the result of a future is whatever is the return value in these two coroutines. And so yeah, this is the correct way to do it, and it's obviously a lot shorter, looks nicer. Let's see, next demo. So now, again,
In the previous demo,
question, yes?
Where exactly does it block and wait for the results?
So where it blocks is actually, it blocks here. So yield from tulip.wait is where it blocks. So it waits for both of them to finish, and then you get the result back. And then what done is it's a list of the ones that were able to finish, and pending is a list of the coroutines that weren't finished for whatever reason, probably errors. Is that another question?
Sure, so it's way cute in the last one. I still find myself having to sort of traverse through each function to find out how control is happening. Is there any way to see more sort of linear, you're going to write in a linear way?
Well, here though, it's not like, you're not, so yeah, I mean, I see what you're saying. That's probably a problem with my demo itself, but there's no, whatever difficulty is coming, I think is not from callbacks, at least, so that's good. I don't know. So yeah, I don't know. You do have to, read the functions to see what's happening, but I'm telling you right now that foo and bar, all they do is make widgets. Yeah, and we're just looking at different patterns of using the Tulip API to do different concurrent things that you might do. If that makes sense. Does that answer your question, sort of, at all?
I think my concern is still...
Okay, yeah. Well, then it's just a concern. I can't. Yeah, sorry. Did I run this demo yet? No, right? Okay, so this one doesn't wait until both of them finish before it logs. So one of them is going to finish earlier, I think. Actually, maybe I'll just run it again. Ooh, look at all these widgets. Okay, yeah, so bar finished earlier this time, and then it printed, and then foo is going to finish later. Okay, maybe that was clear. We'll see. Oh, why did I run it again? No. And here, it's a little bit more confusing, but basically I'm doing the same thing, except I'm using tulip.asCompleted. So this one doesn't actually block the whole time like .wait does. This yield from waits for the first future that finishes, and then prints out the result. And then foo and bar again, they're basically the same. Except one makes 12 widgets, the other one makes 8. So that I make sure one of them finishes first. Any questions about that one? All right. Basically, you're going to just watch widgets being made all night. So this one, we bring in threads because we can't really completely get away from threads. Like, a lot of code runs only in a thread. And remember, like, most of the Python standard library is not written off of Tulip, right? Because Tulip is not in the standard library. And so there's a lot of synchronous code that you're going to have to write still. And you're going to have to write that in a thread if you have a Tulip program. So this one does the same thing, but what's happening is all the work that's happening in bar is happening in another thread, so it doesn't get to print it out until after it's generated all of its widgets. And let's take a little look at the code. So it looks a little different. Not in this part, not in the start function, but and food is still the same, but bar is now a little bit different. So, oh, it's actually got a little too wide. Oh. Okay, so basically there is a function on the event loop object called run in executor. And I don't know why it's called that, but it has to do with like the concurrent module that we sort of mentioned a little bit. So if you pass in none, it just uses, sorry, question?
Yeah, I didn't want to finish the problem with that. So that run executor, does that acknowledge another Python process?
It launches a thread pool. So I was going to...
So then is it affected by the GEL?
Yes. I mean, it's threads, yeah. So if I pass in none, which is mostly what you want to do, it just uses the default thread pool, which I think has 5 threads. I don't remember. Just read the pep, I guess. And then I pass in the function, which is a new function I made called bar synchronous. And this one makes widgets synchronously. It doesn't use yield from at all. And then it collects all the widgets and then prints them to the client after the thread is finished running. So I mean, that's fine to do, but if you can not do that when you're using Tulip, that would be great, because threads, they suck, right? Anyway, so this one is actually almost the same as the previous one, because obviously they all make widgets, but this one actually has the thread talking back to the event loop thread. So here you see that it's happening at the same time, but there's a little bit of extra logging. So like all this logging that's happening is being initiated from the other thread. So if we look at the code, that will reflect that. So foo is still the same, start is still the same. Here in bar, we changed it a little bit. So we're passing in bar synchronous, but we're also passing in extra parameters of loop and client. And inside of bar synchronous, we make a call to the event loop object, and we say call soon thread safe. And that's like the only thread safe function that exists on the event loop object. And so like we're communicating back with the thread. So what we're doing here is we're appending another widget to the bar slot, and we are also logging to the client, sort of from another thread. Yeah.
And so will those run in the thread pool or in the main?
When I call soon thread safe, it's gonna run in the event loop. So you're passing you're gonna pass in the function that you want it to run and the parameters, and then when the event loop has time for it, when it's done doing whatever else it's doing, it's gonna run these two. Essentially, you're requesting it that run a function with these parameters. Yeah, that's a good question. So these are an attempt to show that you can still make something useful, but beyond like making these widget demos. And I'm not going to really go too much into this code, but this one is a very simple regex debugger, essentially. It might not be very big, but so what it does is it just passes messages in between. Oh, oops, I didn't say street. So it'll like do it essentially in real time. And you'll see like at the left column, you see what group returns, what groups returns, etc. And then I can make a little group here. Yeah, and see groups now return scrim. Make another group. I can add a named group, whatever it's called, and so now groupdict returns something. So I guess that's kind of useful, right? If you look at the code, it's actually only a single function. Oh, because I cheated, I actually like put in extra stuff in like a CoffeeScript file. So it's actually not that impressive. But here I made a chat application because you have to make a chat application when you're making web framework now. So you just suffer through my stupid chat application. Sorry. All right. So I'm gonna log into my chat. Ooh, Feihan, right? And then to make sure that it actually works, I'm gonna start up another tab. Let's see, what is it? 8,000? Yeah. Eagle Man. Say, can I see it? Yeah, see. Oh, but oh man, they're the same color. So it's supposed to be randomized, but somehow I got the same color. So dumb. I spent a lot of time with the coloring. Oh, yeah, exactly. I won the lottery. Let's see. Right. I mean, what else is Eagle Man going to say to you? Right. Okay. Oops. All right, and so you can see that. Oh, actually. And then I left the room because I don't want to hear Eagle Man sell me insurance. Yeah. So this one is really short because all it does is essentially event handlers from the client. And all this extra stuff in here is from like the coloring thing, which didn't even work because I got the same exact colors. But like without that, I think this is only like 30 lines because all the framework does is pass messages, and then that's all a chat application is. So yeah, so you can make all types of chat applications with Tulip. Yay. So I guess that's it for my demos. Here are some useful links that you can click on later, assuming I upload these onto the web, which I think I will. I should. And then any more questions? Oh, yes?
At the beginning of the talk, you went through a lot of effort to show how like Tulip should replace Twisted, it seems, because Twisted is difficult to tell the order of the calls. Mm-hmm. But it seems to me, I mean, people have said a couple different times that it seems that a lot of this is just personal preference because it's still can be considered hard to tell what the order of the calls are specifically. And you have to go through and do the same things you would have to do with Twisted or tornadoes or G-events like that. You have to look at the calls.
So to sort of summarize the question, I think you're saying that, well, it's mostly commentary actually, I think. So like you're saying that at the beginning of my talk, I made some effort to make it seem as if Tulip is simpler to use than Twisted, but maybe it's just a point of preference, right? And actually, I can't say you're completely wrong, but I will go back to this particular example, and you can agree or disagree. But like the Tulip version of the same thing, I thought was way better. I'm not claiming that they're both awesome, but at least we get away from this pattern of having to override like a protocol. Like, when you look at this like get body function, do you say, I love this, or do you say, barf? Like what is your reaction? Like, what is your natural reaction, right? My natural reaction is I don't love this. This is something that only a mystical ninja would love, right? I don't know. Does that sort of address your commentary?
I mean, I don't know that the commentary can be addressed. I mean, it's
right. Yeah.
I mean, what I would say is when you look at typical Twisted code or typical tornado code or typical Tulip code, obviously it doesn't look like this exactly.
Yeah, that's true. Yeah, I think it's still asynchronous programming. It's still just going to be hard, probably, and it's maybe Tulip is a step in the right direction. Maybe it's not. It's definitely coming towards us. So yes.
Well, on that note, part of what you were trying to say earlier was selling it was like, so the trace backs and things like that are awesome.
Okay. Yeah.
Do you have any examples or anything like that? Because that, I mean, I'm driven programming is too difficult conceptually, but I mean, the trace back is awesome.
Yeah, maybe I sold that too strongly. We'll see. I could try. I'm gonna try to run it with. But I suck at doing stuff. That's why I actually Right. That's what I'm gonna try to do. But I don't even have my editor open. Right. But you know what? I'm just gonna screw it up even more. So I can't win in this kind of situation. So yeah. So here I'll just be like, foo. All right, and then let's see if I can even find that file. Which one is it? It's 2, right? Well, hey, that's. Oh no, wait, sorry. Yeah.
1/0.
Yeah, 1/0. Oh, see, I suck at this. Okay. Oh, what am I doing? Oh, because I'm running it in Python 2.7. So obviously it's a syntax error, right? All right, here. Now this is going to work for sure. No, it probably won't. Let's see. Is that even the right one? Let's see. Well, this is lovely, isn't it?
You didn't even get started.
I don't think I even got started, yeah. This is why I don't do these things.
Maybe you should try without. Do you need to pass in like localhost or whatever?
Hold on. Actually, maybe I'll just try running it without the error. Yeah, I have no idea what just happened. Yeah, it's the live demo curse. This shouldn't even happen. I've run this before like a million times. Yeah. No, that's a good point though. Are the tracebacks really that much nicer? I don't know because I haven't done it.
You don't have internet. You're trying to connect to a website.
Oh right, I don't have internet. Yeah, you know what? I give up. Sorry.
That's why it's.
No, it's a good point though.
Wait, you said this is Python 3.4?
It's going to be in Python 3.4.
The traceback there says something along the lines of 3.3.
Right, because that's the current version of Python. Yep, 3.4 isn't landing until next year. Yeah. Okay, and then I'm going to introduce the error, and it's going to be amazing. Let's see. Download.py. Yeah, you can't even see it though. Can you even see it? I don't know how to blow this up.
It's totally like
Really?
I mean, the stack's not as deep, but like, there's no call
Right, it's a super small example.
The stack isn't as
Oh, I still don't know how to blow
there's
this up.
still no call stack.
Okay. Here you go. Yeah, I don't know if it's really that amazing. It's such a small program though. It's still not like a good example. I don't have like a large enough program, I think.
We would want to see download and then main. Why do we download?
Yeah, because all the stuff up here, but
It's no worse than anything.
probably not. Yeah.
Even better than
Okay. Was there? Yes.
So do you have any thoughts on the whole kind of like tulip that's carrot? You know, you should stay on 2.7 and do something else. Should you? I mean, what about things that don't quite work right?
Sorry, I couldn't hear part of your question. Things that don't work right. What?
Well, no. So, I mean, maybe this is good if you don't have dependencies on 2.7. Like, what if you have dependencies on that? And what are your thoughts about moving forward versus sticking with the old model?
I mean, this is really like whether or not you can move forward with Python 3 question, right?
Well, I mean,
I think.
Specifically because of this, or the whole kind of asynchronous problem within Python.
I'm not sure what your question is.
There's some nice things about 2.7, libraries that work.
Right, yeah.
Do you think it's worth putting up with that in order to stay with those libraries or moving into
Well, I would.
Python 3.4?
So moving on to Python 3, I think answering your question in a very generic way, I think the state of affairs is a lot better than it used to be. It's still kind of painful, but I think that if you, like my sort of dumb answer to this is if you're on Linux, which maybe you should be on Linux because it's cool, I think you have a lot fewer problems. If you're on Mac, maybe you should just give up. I know, it's really bad.
Yeah.
Right, because like I tried to do pip install twisted and got clang errors all over the place. It works fine 2.7, so like why should I move to 3 if I'm using twisted? But I've been on Linux, it's like it works just fine, no problems at all. Or or maybe the answer is use Vagrant, use a virtual machine. I think the 3 situation on certain platforms is bad. On other ones, it's not as bad. It's kind of a weird platform-specific thing, I think. Yeah, I don't know. Yeah.
So I have a dumb question.
Mm-hmm.
So I don't basically programming at all. I don't read a book with it.
Yeah.
Are there common cases where programmers should be using this sort of programming paradigm or they're not?
Yeah, so for asynchronous programming, definitely for like certain kinds of network programming, it's probably a good idea. Also, if you're, all these demos are technically just GUI demos, right? I'm connecting with a front end, and then there's a back end that they're exchanging messages between them. But in general, any kind of visual programming needs to be event-based. So that's another example of where you need asynchronous programming.
Second question.
Yeah. Mm-hmm.
So this language is like Go.
Yeah.
How does this relate to their paradigm? Or I think Clojure.
There's a Go guy who did the Go guys. He's here, or did he like die already?
I died.
Oh, okay, he's dead. Yeah.
I'm not good at it though.
Yeah, I don't know enough about Go to answer that question.
So Clojure recently released the core async library, which is
Right, and I haven't looked at Clojure, but I think Clojure doesn't it use like the agent thing or is that Scala? Yeah, that's Scala. Yeah.
Clojure uses immutable objects, which is really awesome. So
yeah,
it's way easier to do asynchronous stuff because you can work on the same objects and not have to worry about affecting them badly in them.
Yeah, why don't we just mention Erlang while we're at it? Like Haskell, monads, right? I'm sure you can do something amazing with them. Right.
You just use Python because you want to actually get them.
Yeah, or that. Oh, yes.
How does Scuba compare with considering your cars with Piston?
Oh, like how does Tulip compare to Twisted in terms of performance? Yeah. I'm gonna guess it's worse right now, just because it's so new, and it's like like I don't want to dump on other people's work, but like in Python, when Python 3 first came out, like strings were kind of bad, right? People were complaining about that. It's really new. Like I don't think you can compare it directly until like Tulip actually sort of matures. So yeah, I don't know. Yes.
So if somebody writes some really wacky protocol parsing code in Twisted for some random protocol, will I be able to take advantage of that?
Yeah. So Guido said. So the question is, will you be able to take advantage of like wacky protocol code that's written in Twisted? Will you be able to use it in Tulip? Guido said explicitly in his keynote that if he doesn't have like good interoperability with Twisted and Tornado, etc., that essentially the project has failed. So assuming it doesn't fail, you should be able to do that. It's a very optimistic answer. All right, were there any more questions? All right, thank you.
We're working on that.